Okay, so today we will be discussing about 11th lab program. Okay, so 11th lab program is on graphs. Graph is also one of the data structure. Maybe we have seen that in the first module related to classification, primitive and non-primitive, and also under that we had linear and non-linear. Okay, so graph comes under non-primitive and non-linear data structure. So 11th program is on graphs. Okay, so we have to check with what are the operations to be performed here. Okay, so here you need to design and develop, implement a C program for doing the following operations on graph for cities. Okay, so when you consider graph, I told you earlier case also, when you consider graph, what is the best example to understand graph is your real world example is can be traveling from one city to another city. Okay, so every node you can relate this to tree as well, tree data structure as well. So every node in the tree, if you consider that node as a city, I can connect that via your what is this? Maybe you connect with your edges. Maybe you know what is your vertex and edge for a particular graph. So we will understand with respect to that. So best example to understand graph is you'll be having two cities and you can travel to two cities if you have a path. Okay, so path can be anything, either can be direct path. Suppose you are traveling from Tumkur to Bangalore, you can directly, you have a single path. Okay, otherwise suppose if in between you are traveling from other village, you need to connect to Tumkur, then you have to visit Bangalore. Okay, so this is the best example. Traveling can be the best example for the graphs. We will understand with example how it is related, and also while traveling always you check for the shortest path. Okay, but in this program we are not identifying any shortest path for in between two cities. Okay, here is only to represent cities and also reach each of the cities. Okay, for reaching and visiting each of the cities you have some different methods here. Okay, so this is an implementation on the graph concept. Let us see what are all the operations to be performed. Okay, so first operation is to create a graph of n cities using adjacency matrix. Okay, we will understand what is adjacency matrix. What is the first step here? Here you need to create the graph. Okay, and also you have to mention what is the value of n. N depends on the user input. User can give any value for n. So if you have n is equal to 3, it indicates you have 3 cities. Okay, that it should be created. Okay, that is the first option, to generate the graph and use your value of n for generating. Okay, so in between you can visit each of the cities. That is, you can say best example is traveling. Okay, so that can also be represented with adjacency matrix. Let us understand it later. Okay, so as of now first operation is to create the graph for n number of cities. What is the next operation to be performed? Here you need to print all the nodes reachable from a given starting node. Okay, so suppose if your starting place is Tumkur and you have indicated 3 more cities after Tumkur, you need to check the reachability, whether it is directly reachable. Okay, so and how it can be reached, what are all the paths you need to follow. Okay, so those are the things to be identified in the second step, to print all the nodes reachable from the starting node. So starting node can be my starting place, that can be the example of Tumkur. Okay, so from Tumkur if you want to visit 2 or 3 cities, what are all the in between reachable cities you can identify. Okay, in between you may get cities, so we will check for that particular reachability here. So the best example here, it is the traversal method. Okay, we will be traversing each of the nodes. If you compare with your tree data structure, we know what is a traversal. Okay, it can be compared with the traversal method for reaching each of the cities. Okay, and you need to consider a digraph here. We will understand what is a digraph. Usually digraph indicates it is the directed graph. We have a direction from source to destination, and using methods, you have some methods for traversal. Okay, what are all the methods? One is DFS, another one is BFS. BFS and DFS, these are all the traversal methods. Okay, DFS stands for depth first search. DFS stands for depth first search, and BFS stands for breadth first search. Okay, depth wise and breadth wise, we'll be going for the searching operation or visiting each of the nodes. Okay, so using any of these two methods, you must be able to reach the nodes for the given source node. Okay, you have to specify what is your starting node. Starting node can be, you can relate it to starting city. Using that starting city, you need to check the reachability of other cities based on the value of n. You need to specify the value of n, and from the starting node, from the starting city, what are all the other cities that can be visited based on the user input that should be identified, and that is using any of these two methods, DFS or BFS method. Okay, so this is actually the question specified using this particular operations we need to implement the program. Okay, so before starting, we shall understand some of the basics required for this program and what are the different graphs available. This is visible.
Yes, ma'am.
Okay. So when you consider graph, so you can relate this particular concept along with your tree structure where trees will be having nodes. Okay, so the cities can be indicated here with the nodes. Okay, so I can indicate different. Suppose if you have three cities, I'll consider a simple example. Okay, so consider you are having three cities: Tumkur, Bangalore, and Mysore. Okay, this is just for an example. If you have three cities, I can visit. This is my, suppose Tumkur is my source node. You can consider any of the nodes as a source node. It is not mandatory that one of the nodes should be source. You can consider any of the node as source. How do I visit? Suppose if you are visiting from source nodes to destination node, consider Tumkur is the source node and destination is Bangalore. If you have a path, you have to indicate an edge here. Okay, similarly, if you have a path from city Tumkur to Mysore, you can directly link it here, and if you have a path from Mysore to Bangalore, you can link it here. Okay, so this is an example graph where you will be having you will be considering three cities. What is the value of n here? N value is equal to 3. Individually, these are all the edges. Okay, we have three edges and nodes are three. These nodes are also called as vertex. Okay, maybe you have studied this earlier, anywhere in the previous edges and the vertex. Heard of this thing? No? Anywhere have you come across graph concept in the previous semester?
No, ma'am.
No, ma'am.
Okay. Okay, so let us understand here. So this nodes I can consider as the vertex, or it is singular, it is vertex, or if it is plural, we'll call it as vertices. Okay, so each of the nodes we will be calling that as a vertex, and you can have a path. So path indicates those are all the example for edges. It is not mandatory that every node should have a path. Okay, so I can also have nodes like this. Suppose you have three cities. So I have a connection between Tumkur and Bangalore, and I have a direct path from Bangalore to Mysore. I may neglect one of the path here. Okay, there is no direct path from Tumkur to Mysore. In that case, what is the reachability? What are all the places you will be visiting for reaching Mysore from Tumkur is? So first is I need to visit Bangalore, then I have to visit Mysore. Okay, if you don't have any path. Okay, so this is just an example of simple graph with three cities. If you have a path, you will be indicated with the edges. These lines are specified as edges. Okay, so these nodes are indicated as vertex. Every vertex, you can consider any of the vertex as a source node and any of the node as a destination node. You need to identify what is your source node. Any of these nodes can be source. Okay, so any of this can be source or it can also be the destination. It is not mandatory that in trees it was having a root node, right? Don't get confused with tree data structure. There will not be any root node here. It is related to your source and destination. Okay, so any vertex can be either source or the destination. And coming to types of graphs, when you come across with the graph, you can see there is no arrow mark indicated here. Okay, so if an arrow mark indicated here, this is an example of directed graph. Okay, this is an example of directed graph, or I can also consider that as a digraph. Okay, if you have a direction, it is called as directed graph. Okay, so you will be having a direction indicated for the particular destination from the source. You can see here when you look at this particular directed graph, you have a direction from one city to another city. So from Tumkur, I can reach Bangalore, but I cannot directly reach Mysore. Why it is not possible? Because you can look at the direction here. So from Mysore, I can directly reach Tumkur, but there is no direct path from Tumkur to Mysore. But how do I reach it? So from Tumkur, I have to visit Bangalore, then I have to reach Mysore. Okay, so that is the concept with directed graph. So in the graphs, either you may have a direction or you may not have direction. Suppose if you have a direction, it is called as directed graph. It is when it is not having direction, it is just called as a graph. Okay, and one more type is present in the graph. So for each of the edges, you may also have weights. Okay, so we will be studying that in the theory. It is not required now, but just for an example, you should know for every edges you may also have a weight. So what is the advantage of having a weight on particular edges is you can identify the shortest distance. Okay, so shortest path. Always when you want to visit a city, you will be searching for the shortest distance or the shortest path. So this weights in between, suppose if you have any other nodes, suppose you have some other weight, okay? So consider you have different directions to visit Tumkur, okay? Always we will be searching for the shortest distance. Okay, when you have one here, so to reach Tumkur, you need to follow the proper path so that the shortest distance will be identified. Okay, so as of now, don't worry about the weights. So weights are required only to identify the shortest distance. But this program is not related to shortest distance. You will be identifying what is the source node and what is the destination node. How do I reach the destination node? Via two types of methods. Okay, so what are the two types of method? One is BFS, which stands for breadth first search. Okay, we are going to study this in theory as well. This is breadth first search method, and second is BFS method. So it is stand for depth first search. So we have these two methods for doing the traversal. These are the types of traversal methods. Okay. So the name itself indicates breadth first search. So you'll be searching with the breadth wise. Okay. Depth first search, you'll be searching depth wise. So how do I identify depth? You already know the depth in the tree data structure. So depth and level you have identified. Whereas breadth will be related to total number of siblings. Sibling wise, you will be doing the particular traversal method. We will understand BFS and DFS method. Okay, as of now, you consider that we will be using these two methods for particular traversal. So now, before going to the BFS and DFS method, now let us check how this graph can be represented. What is the method for representing? So for representing, we will be using adjacency matrix or adjacency list. We have two types of memory representation. One is I can directly go with adjacency matrix. Another one is directly you can go with adjacency list. Okay, as of now, adjacency list is not required. We will go with adjacency matrix. Okay. So what is the advantage of writing this as an adjacency matrix is I can easily know what is the particular path present from source to the destination. You can consider any of the nodes. This adjacency matrix will tell you whether there is a path from the source node to the destination node. Okay, I just consider the simple example. Okay, so let us do it for normal graph. I just eliminate the direction here. I'll tell you with the direction also. Let us understand for the normal graph first, then we will go with the directed graph. Okay, so let us do it for the simple example only. Consider three cities itself. Okay, so we have three cities. There is no weight. Okay, so when you have three cities, I can consider this as I can represent this via the adjacency matrix. Okay, so it will be considered as node 0, node 1, and node 2. Individually, cities can be considered with 0, 1, 2. So let us see how this matrix can be represented. So when you have a matrix, it will be having two-dimensional matrix with total number of nodes present in the graph. According to our example, we have three nodes. Okay, so when you have three nodes, it is a 3 cross 3 matrix, 3 rows and 3 columns. I'll be writing it as 0, 1, 2. Okay, 0, 1, 2. Okay, so if you have a path, we will be indicating that with 1. If you don't have path, we will be indicating that with 0. Okay, so I'll just write it here. If there is a path, direct path, then we will be writing that as 1, and no path will be indicated with 0. Okay, so this you should remember. If there is a path, we have to substitute 1 in the matrix, and if there is no path, we have to substitute 0. Okay, so with that example, you can consider the node 0. It will be consider. I can consider the row value and the column value first. Okay, when you start with the source node 0, so do you have any path to visit 0 itself? Do you have any self loop? Graph can also have self loop. How do we indicate self loop? This is the way an arrow mark which will be pointing to itself. So that self loop will be present only in the directed graph. Okay. As of now, we are not considering the directed graph. There can also be a self loop for the particular node. As of now, don't worry about the self loop because it is not a directed graph. Okay, so do you have any path from 0 to 0? I don't have any path. In that case, what is the meaning here? I can indicate that value with 0 in this location. Okay, because there is no self loop and it is not a directed graph, directly I can specify that equal to 0. Okay, so then I will check from next one. Okay, so I will start from the source 0 and check whether I can reach 1. Okay, row 0 and column 1. I'm considering row 0 and column 1. So do you have a path from node 0 to 1?
Yes, ma'am.
Yes, ma'am.
So when you have a path, what should be the value stored here? I have to
1.
store 1. Okay, so again you check from the source node 0 to the destination 2. Okay, sources. So left side row I can consider that as source. Okay, row you can consider that as source. Column I can consider that as destination. Okay, so from source 0, I have checked with destination 0. Column is destination. Okay, I can indicate here destination, column destination. So similarly, check for 0 to 2. Do you have path from 0 to 2?
Yes, ma'am.
So there is a path I can indicate 1. Now go with 0th row is completed. Go with the source node 1. Okay. When you go with source node 1, so can I reach 0 from source node 1? 1 to 0, do you have a path?
Yes, ma'am.
So what should be the value stored here? I have to store 1 here. Similarly, so from the source node 1 and destination is also 1, there is no self loop. What I can indicate, I can specify 0 here. Okay. So similarly, check with source node 1 and destination node 2. So when you have destination 2, you have a path. From 1 to 2, you have a path, that is from Bangalore to Mysore, you have a path. If there is a path, indicate that with 1. Okay, so now go with the source node 2. Now 2 becomes your source node. Okay, so when 2 is the source node, you check with reachability of other particular nodes. So from 2, I can visit 0. Okay, so from 2 to 0, there is a path, specify 1. And from 2 to 1, I have a path, specify 1. From 2 to 2 itself, I don't have any self loop. I can be indicating that with 0. Okay, so this is called as adjacency matrix. Adjacency matrix and adjacency list are two types of representation used for representing your graphs. Okay, so you should remember that when you have a path, it will be indicated with 1, and when there is no path, it should be indicated with 0. Okay, so this is an example where there is no direction specified. Okay, when you look at this edges, these lines will be considered as paths or edges. There is no direction specified. If there is no direction, I can say that it is bidirectional. Either I can go from 0 to 1 or I can go from 1 to 0. Both are okay. Okay, so let us understand the same thing for bidirectional graph. As of now, you understood, right? Any doubt? Any doubt with the adjacency matrix? So if you have another node, how do you write it? So third node, if there is a third node, you will be adding another row and column. Okay. So another row and column can be added, and similarly you check the reachability from each of the source node, that is 0, 1, 2 and 3. Any doubts?
No, ma'am.
Everybody understood the writing adjacency matrix. So this is the input for this particular program. Okay, input is two-dimensional matrix. You have to give this as an input. You have to specify what is your adjacency matrix. So to identify this adjacency matrix or to write this adjacency matrix, you should have a graph here. Okay, so without graph, directly you cannot give an input. It may not give you the proper result. Okay, make sure that you write the graph, and for a graph you have to write down the adjacency matrix, then followed by the input for your program. Okay, so this is an example for normal graph. Suppose if it is a directed graph, let us understand the same thing for the directed graph. Consider the direction like this. Okay, randomly I'm giving a direction. So now let us see for this one. Okay, and also I'll add a self loop for one of the particular node. Okay, so can you people just think of adjacency matrix for this graph?
Yes, ma'am.
So consider source node 0. From 0 to 0, do you have path?
Yes, ma'am.
Yes, ma'am.
So what should be indicated here? 1.
1.
Okay, 0 to 1.
Yes,
Yes,
ma'am.
ma'am.
1.
Okay, 0 to 2.
Yes, ma'am.
Yes,
1.
ma'am. 1.
Okay. What about 1? 1 to 0?
No,
No,
ma'am.
ma'am. 0.
So there is no direction, hence what should be indicated? You should have 0, correct? 1 to 1?
No, ma'am. 0.
0. Okay. 1 to 2?
Yes, ma'am.
Yes,
1.
ma'am.
1. Okay. So similarly check for 2. 2 to 0?
0.
No, ma'am.
0.
So when you look at this particular node 2, do you have any outward arrow?
No, ma'am.
No, ma'am.
So when you don't have any outward arrow, I can say that all the values will be equal to 0, correct?
Yes, ma'am.
Because from 2 I cannot visit any of other nodes. Okay, so we will study more of the details like in degree, out degree. We will be studying that in theory. Okay, so as of now, you consider that if you have a directed arrow, in that case, you will be having a path. Okay, so if you don't have any outward arrow, you can say that it is not reachability. There is no reachability. Okay, from Mysore, I cannot reach any other node. But from Tumkur, I can reach Mysore. From Bangalore also, I can reach Mysore. That is possible. Okay. So this is the input. Okay. Based on this input, now what is your question? Okay. Look at your question first. According to our question, what should be first thing? First thing is I have to create a graph for n number of cities and also specify the adjacency matrix for creating it. Okay, first step is done. We understood what is a graph and what is a what is a directional graph and how to create the adjacency matrix. The first thing is done. So using the particular matrix, okay, two-dimensional matrix, I can represent the graph for n number of cities. Okay. Only thing is how do you implement this? Only thing is you should know what is your adjacency matrix. Okay. If you know the adjacency matrix, you know one will be indicated with path, so your graph will be created. Okay. So after it is created, so first implementation is easy because it is just creation of that via a two-dimensional matrix. You know how to do it via two-dimensional matrix, how to read two-dimensional matrix. Okay. So second thing is, read the second question. We need to print all the nodes reachable from a given starting node in a digraph. They have mentioned that it should be a directional graph. Okay. So you should have a direction and specify that. So for a given source node, starting node is the source node, you need to check what are all the other nodes to be visited. Okay, and what should be the method you have to follow? You have to follow any of the method like DFS and BFS. So I'll just explain the concept here. So, one second. Okay, so when you consider the source node 0, okay, so consider the source node is equal to 0. When source node is equal to 0, what are all the reachable nodes? Can you people tell me? From 0, what are all the reachable nodes? From Tumkur,
0
what are
to
all the
0.
cities you can visit?
1, 2.
What about 0?
0 to.
Yes, ma'am. 0,
Yes,
1, 2.
ma'am. 0 to 0. 0
Because
to
there
1.
is a self loop, it is 0, 1 and 2. Okay, so I can easily identify this in the matrix also. Okay, whenever you have a path, it will be indicated with 1. Okay, so according to your question, you need to give what is your source. Okay, initially I'll give source is equal to 0. When source is equal to 0, you need to print. Okay, you need to implement what are all the reachable cities or what are all the reachable nodes in the particular node. Okay, source cannot be always 0, it can be equal to 1. 1, it is equal to 1. What are all the reachable nodes according
1
to
to
the
2.
graph?
2.
So I can reach only 2, correct? From B is Bangalore. From Bangalore, I can directly reach Mysore, but there is no other path available from Bangalore. Okay, only thing is from Bangalore, I can reach Mysore. What about source 2? From 2, do you have any path?
No, ma'am.
So here it will be No nodes, correct? Yes?
Yes, ma'am.
Yes, ma'am.
So that is the thing you need to implement here. Okay. So first input, you know that we have to create a two-dimensional matrix, and based on the input graph, you need to write the adjacency matrix. Okay. So when you give the adjacency matrix, using this adjacency matrix, I need to do the traversal. Okay. We are doing traversals here. So traversal can be visiting each of the node. Okay. You are checking whether there is a path. If there is a path, then you have to identify what are all the paths that can be visited. Okay, so for doing that, we'll be using two methods, BFS and DFS method. Okay, so using stack and queue operation, we are trying to implement this. Okay, so I'll just one second. One second, I'll open up new because it is required. I'll retain that as it is. First, I'll just explain what is BFS and DFS, then we will go with implementation. Is it visible?
Yes, ma'am.
Okay. So I just actually this BFS and DFS method can be applied for trees and can be applied for graph also. Okay, breadth first search and depth first search can be applied for both trees and graphs. We will understand method like this. Okay, I'll just initially tell you for the graph for the particular tree. Consider you have some nodes like this. Actually, these two are very important. I think this you are also going to study in next semester. Okay, algorithms subject you are going to study in detail about BFS and DFS, and also in theory we will be studying what is BFS and DFS method. So just I'll randomly consider a tree. Okay. So if you consider DFS method, DFS is depth first search. Okay, so the name itself indicates we have to start searching according to depth wise. We already know what is the depth of a tree, correct? When you consider this tree, what is the depth of this tree?
3.
It is equal to 3 depending on the maximum level, correct?
Yes, ma'am.
Okay, so always, how do we go with depth first searches? We will be searching nodes according to depth wise. Okay, downward direction, depth wise. If I start it with A, what will be my sequence of DFS is, it is the depth wise search from A. Immediately I'll move to depth wise, that is downwards. Okay, so it will be B followed by D. After this, then we will go with the remaining unvisited node. Okay, so when you go with this left node or the left part, B and D is visited. Similarly, you check for other unvisited nodes. Okay, unvisited nodes are C and E. Okay, it is also done depth wise, downward direction. Okay, so C will be visited first, followed by E. Okay, so this is the depth first search. Depth wise, we will be searching. Suppose if it is BFS method, BFS stands for breadth. Okay, so breadth wise is, suppose if I start from a tree node, that is the root node A, what is my next unvisited node? I can check, go with B. After B, it is not depth wise, it is breadth wise. I'll immediately move to its next sibling. It cannot be called as sibling. Immediately you will be moving towards the right direction. Okay, you may have siblings or you may not have siblings. Immediately you will be going with the right direction. What is there in right direction? It is C. Okay, so in this level, all the particular nodes have been visited. Then you come to the next level. So in the next level, again, it is breadth-wise search. Okay, so in breadth-wise search, what is the node to be visited? It is D. finally it is E. Okay, so it is very simple actually. Searching is very simple here. DFS is you can directly go with depth, downward direction, whereas breadth, the name, it is general meaning, right? So breadth wise it is you will be considering from left to right. Okay, so normally you can apply this method for doing the traversal depth wise or the breadth wise search, whether it is for tree or whether it is for graph. You can apply for the both the cases. Okay, as of now you understood DFS and BFS for this particular graph. We will check with another example also. Any doubt? I'll give you graph example after this. Any doubt?
Ma'am, BFS ಇನ್ನೊಂದ್ಸತಿ ಹೇಳಿ ma'am.
So DFS is depth wise, that is downward direction, whereas coming to breadth, BFS method, what happens after visiting your first node, immediately you will check for the next unvisited node in the next level. What is that unvisited node in the next level? That is B. Okay, so you will write it as A and B. After B, you will not move downwards. If you move downwards, it becomes depth first search. Okay. In that case, in DFS method, it is breadth wise. Breadth wise means in that particular level, you will visit all the nodes. Okay. From B, what happens? You will directly move to the right side. Okay. When you move to the right side, what is the next node you are having? It is equal to C. Correct? Okay, so you will write it as it is. ABC is written as it is. So in this level, first level and second level, all the nodes are completed. Then you will move to the next level. When you move to the next level, what is the first unvisited node? That is equal to D, correct? You will write D as it is. Okay, the next unvisited node is D. Then you will move to the right side of that. Okay, BFS I can say it is towards the movement, right movement. Okay, width actually ನೀವು ಹೆಂಗ್ ತಗೊಳ್ತೀರಾ? Usually depth and width, height and width ತಗೊಳ್ಳುವಾಗ height will be, I can consider height as a depth, correct? Breadth, can I consider that as a width? Correct? Okay, so
Yes, ma'am.
BFS method follows that particular rule. After visiting D, it directly moves to E. Okay, so E is finally printed. That is the difference between DFS method and BFS method. DFS, depth wise you visit all the nodes, then whatever the remaining nodes are available, that is also searched via depth wise. Okay, but in BFS what happens, once you visit a node, you immediately check what is next node available in the same level. Okay, then you print that particular node, then you will be moving to the next level. Okay, any doubts now? Everybody understood the difference? I'll give you one more example. Tell me for this one. Okay, this can be an example for graph as well. Okay, so this is the graph given. Apply the same technique for this particular graph. Tell me what is DFS and what is BFS. Start from the first node.
And both are equal to 0, 1, 2.
Both are equal to 0, 1, 2. Everybody
Yes,
agree with that
Yes,
result?
ma'am.
So DFS, how do you do? You start from 0, then you visit depth wise, you check, there is no other node after this. One ಆದ್ಮೇಲೆ ಬೇರೆ node ಇಲ್ದಲೇ ಇರೋದ್ರಿಂದ you just immediately move to the next unvisited node in the downward direction. When you go with downward direction, the remaining node is equal to 2 itself. Hence it will be 0, 1 and 2. Okay, so then when you go with BFS method, similarly you start with 0. What is the in next level you go with the unvisited nodes. What is the unvisited node? 1. Then you move to the rightward direction. When you move to the rightward direction, it is equal to 2. So in this method, both BFS and DFS results in the same sequence. Okay, I'll give you one more example. Tell me for this one. Okay, so it can also have direction. I'll give the directed graph itself because in our example we are doing it for the directed graph. Okay, so whatever we are trying to implement today, it works for both directional and also non-directional graph. Okay, so tell me for this one.
0, 1, 3, 2.
For which one?
DF, DFS.
DFS.
DFS is depth wise. It is 0, 1, 3 and 2. Okay, what about BFS?
0, 1,
0,
2, 3.
1, 2,
0,
3.
1, 2, 3.
0, 1, 2, 3. Okay. Any doubts in this? Everybody understood BFS and DFS?
Yes, ma'am.
Ma'am, left child, right child, ఇప్పుడు ఇద్దరా ma'am?
No, I'm telling only for the graph here. Don't worry about trees now. Okay, it is an example of graph. Okay. Any doubts? So can you write for any of the particular trees given? Suppose if you have consider as you asked for right child also. Suppose if you have like this, how do you do? As I said, it can be applicable for a tree also. Can you tell me DFS and BFS for this?
DFS 0, 1, 3, 4, 2.
4, 2, correct? Okay, then what about BFS?
0, 1, 2, 3, 4.
Understood?
Yes, ma'am.
Okay, it can be done for both trees and graph, but as of now we are not doing for trees. We are doing for the graph. If you have 2 or 3 child nodes, it is also done depth wise only. Okay, so we will start from 0, 1, then we will visit 0, sorry, visit 3. After 3, again it is depth wise. In this depth, if you have unvisited node, what is the unvisited node? 4 is my unvisited node. Okay, I'll write 4. Then we will go with other unvisited node for 0. Okay, that is equal to 2, which is written as which is written for DFS method. Okay, similarly, if you go for BFS method, 0 is written first. After 1, we will move to the rightward direction. When you move to the rightward direction, 2 is considered. Okay, again go to next level. In the next level, 3 is my unvisited node. Write the unvisited node. Similarly, move to the rightward direction, which is equal to 4. Got it now?
Yes, ma'am.
Okay, so this particular concept, actually now we know what is BFS, DFS, and also we know how do we write the adjacency matrix. So we have to use adjacency matrix along with this particular DFS and BFS method for checking the reachability of particular node to the destination nodes. Okay, for any source given, we need to print whether we can reach other nodes. If it is reached, then what are all the other nodes that can be reached? Okay, and this is done with respect to here. Actually, in question they have mentioned that either you can use BFS method or you can use DFS method. Okay, but according to your question, we'll do slight modification. We'll implement both because it is required for theory as well. We will implement both. So what we can check is we can check the reachability via BFS method. We will use BFS method for checking the reachability, and DFS method can be used for checking whether the graph is connected or not. Okay, so whether the graph is connected or not. What is the meaning whether graph is connected or not? So whenever the particular nodes, when you consider all the nodes, so from a particular node, if I can reach all other nodes, then I can say the graph is connected. Okay. So if I cannot reach all other nodes, in that case I can say it is not connected. Okay. I'll give you the example for that. Okay, so consider the same example 0, 1 and 2. Okay, so I'll not specify any direction. So when you look at this graph, any node, you can consider any of the node. From any of the node consider, can I reach all other nodes? Is it possible?
Yes, ma'am.
From 0, I can visit 1, 2. From 1, I can visit 0 and 2. From 2, I can visit 1 and 0. So in this case, since I can reach all the nodes available, what I can say, this is called as the graph is connected. Okay. So this connectivity can be checked with your method, that is DFS method. DFS method we are going to implement today for identifying whether the graph is connected. Okay. Suppose for the same example, if I eliminate this, can you say the graph is connected?
No, ma'am.
Is it now connected?
No, ma'am.
It is not connected. Why it is not connected? Because what is the reason?
Because we can't reach one from two.
Correct. So from 1 you cannot reach 2 and from 2 also you cannot reach 1. But if you follow the path from 2 to 0, 0 to 1, you can go with that. Okay. Consider you have a direction. I'll give another example for the directed graph. You have to tell me whether it is connected or not. You may have the direct path or you may not have the direct path also. Okay, it is not mandatory that direct path irbeko anta. You can also there can be in between nodes available also. So tell me for this graph, is it connected or not connected? There may not be any direct path also. In between, you can visit other city and reach your destination. Suppose if you are in Tumkur, from Tumkur, if I want to reach Mysore, I can reach it via Bangalore. Even then, it is connected.
Connected, ma'am.
Connect.
Is it an example of connected graph?
Yes, ma'am.
Yes, ma'am.
So it is an example of connected graph because when I start with the source node, if you consider T, that is Tumkur as the source node, I can reach Bangalore, I can reach Mysore, and I can reach some other place like Hubli and again come back to Tumkur. Check with Bangalore also, if Bangalore is source node, I can reach all other cities because the direction is written such that it is a connected graph. All the cities are connected. In between, you can visit other city to reach the destination. Okay. Suppose instead of a arrow like this, if suppose the arrow is changed, tell me now whether it is a connected graph.
No, ma'am.
So when I change the direction, what happens? Some of the cities cannot be visited. In that case, I can say the graph is not connected. Okay. So in this particular program, we are trying to implement both DFS and BFS. BFS will give you the reachability, what are all the cities that can be reached from the source node, and DFS will give you the details of whether the graph is connected or not. Okay, so this is we are going to implement using stack and queue concept. Okay, so DFS will be using stacks, whereas BFS will be using queues. What is the logic for implementation? Okay, so when you consider any of the graph, suppose if this graph is considered, if I want to implement this DFS method, what happens? I'll consider a stack. Okay, so along with this stack, you need to identify the adjacency matrix Okay, we will implement that and we'll see. Okay, so when you consider DFS method, what happens? Initially, my source node will be placed onto stack. Okay, so consider source is 0. 0 will be placed onto stack. Immediately after that, since it is a DFS method, we will check for the next unvisited node. What is the unvisited vertex here? 1 is the unvisited vertex. Okay, 1 will be placed onto stack. Then we will check whether next unvisited, whether we have any unvisited node after 1. If there is no other node, then we will go with visiting the next level. Okay, in the next depth first search method, we will visit the other unvisited node. Okay, what is the unvisited node? 2 will be placed onto stack. Okay, so along with that, we will be using another array called visited. Okay, we will check with that later. As of now, for DFS, we will place particular elements, that is each of the visited nodes onto your stack. Okay, on top of the stack, you can find out the last node which you have visited. Okay, so after you complete, you can pop out all the elements and print it, but it is not exactly the same method we are following. We will check with the implementation later. As of now, you understand that every node which you will be visiting, you will be placing onto the stack. What happens to your BFS method? Suppose for the same graph, if I want to apply BFS, so consider you have a queue like this. Okay, so initially the front and rear will be pointing to -1 or 0. Okay, as soon as you visit a node, that node will be placed by incrementing rear to the particular place. Okay, rear will be incremented and initial source will be placed on top of the placed onto your queue. Okay, so then to check with the next node, how do I check with the next node? I will be deleting the element from the queue. What is the element to be deleted? 0 is my element to be deleted. Okay, because I need to check from this 0 what are all the other nodes visited. Okay, similarly you go with placing 1, 2 for the particular queue. Okay, as of now you are not understanding anything. We will go with implementation and do the tracing, then we will understand. Okay, so DFS we will be indicating that stack operation, whereas BFS will be indicating the queue operation. Okay, so any doubts with the exact concept of graph and how do we implement? Any doubts? Shall we start with the implementation? All of you understood what are all the operations to be performed, right?
Swam.
Okay, we will start with the implementation, and it is also an example of a menu-driven program. And the method, DFS method we are implementing, actually in the question they have not mentioned that both should be implemented. So it is only for your understanding, I'm just implementing both BFS and DFS. And in question also they have not mentioned that whether we need to check whether graph is connected or not. Okay, because we are already implementing DFS, we can also print that whether it is connected or not. Okay, so we will understand that method. So include the normal files, header files. The program looks simple if you understand it properly. Okay, there is no structure concept here because it is just stack and queue operation. We will be using array concept here. That is more than enough. Structure is not required. Okay, so I'll start with the main. So go with your menu driven option. Okay, in choice. So how do you read a two-dimensional matrix? In C?
I'm using two for loops.
Two for
So you need two for loops, one for the row, another for the column. Hence I'll take two variables I and j. Okay, and you need the value of source. Okay, source is required because you need to check for reachability. From source, what are all the other nodes that can be visited? Okay, so hence I'll take the variable called source, and I'll take a temporary variable called flag, and I'll initialize this to be equal to 0. Why flag is required? So we are checking whether the graph is connected or not. Okay, for checking the connectivity, whenever it is equal to 1, we say that it is not connected. We will understand that later. Okay, this flag is required for identifying whether the graph is connected or not. Okay, afterwards, to read two-dimensional matrix, I need a variable. Okay, I need a adjacency matrix. Hence, for adjacency matrix, I'll just write it as adjacency, and it is a two-dimensional matrix. Okay, it can be considered as two-dimensional matrix. So, when you don't have any particular direction, or suppose if you have a normal graph, so BFS and DFS methods, while implementing, you may visit each of the node multiple times. Correct. So sometimes you may already have visited that node. It is not that you will be having only 3 nodes. You can have multiple nodes or not. Okay. So when you have multiple paths or multiple cities, so to check whether that city is already visited or not, it will be difficult. Okay. So to identify that, what we'll be doing, we'll be considering an array called visited. Okay. It is an array, and this array is initialized to 0. All the values in this array is initialized to 0. Okay, why it is initialized to 0? Whenever a node is visited, I just explain like this. 1 second. I'll tell you why visited array is required. Okay, consider we are considering visited array now. Okay, so this array, maybe it depends on the size of your cities. If there are 3 cities, consider 0, 1, 2. Okay, and we are initializing all the values of this visited array to 0. Okay, what is the use of this visited array is, suppose your source node is 0. Okay, you are applying some BFS or DFS method. From source 0, you are trying to visit another node. From 0, if you start, I can say 0 is visited. So as soon as you visit a node, what happens to the value which is present in visited array is, instead of 0, we will be making it equal to 1. Okay. So suppose if you are moving from 0 to 1, in that case, it indicates 0 and 1 both are visited. When both are visited, what should be placed in this location? You will be placing it equal to 1. Okay. Suppose if all the values are equal to 1, what is the meaning in visited array?
All the nodes are visited.
Graph is
Okay.
connected.
All the nodes are visited. Okay. For checking the visited nodes, because sometimes it should not be repeated. Every node which you have visited, only once you will be visiting. It is not multiple times you have to visit a node. Okay, if it is visited, all the values will be equal to 1. Okay, so the advantage of this visited is you can also check whether the node is visited, and another thing is you also check whether the graph is connected or not. Okay, if all the values are equal to 1, I can say it is connected, because from every node I can visit other node. That is the advantage of visited array. Hence, in the program, we will be considering an array. Okay, initially this visited is an array, single dimensional array it is. Okay, it depends on the value of n, and it is initialized to 0. As of now, it is initialized to 0. Whenever you visit a node, you make it 1 at that particular index location. Okay, so and you need the value of n for identifying the total number of cities. Okay, so this is about the declaration. Choice I and J for two-dimensional matrix. Source is for source, identifying what is your source node, and flag is for checking whether the graph is connected or not, and adjacency matrix. Visited is for checking whether the particular node has been visited or not, and N is for total number of cities. Okay, so then go with the clear screen option. Okay, so afterwards specify normally like other programs, specify the switch display. Okay, menu options. Enter program to perform graph operations. Okay, so then specify the choices. What can be first choice? According to the question, it is to create a graph of n cities. N should be given by the user. N cities. Okay. Second option is to check for the reachability from source node to the source node to other nodes. It is not destination. You are checking the reachability of other nodes. Means what are all the cities I can visit from the source node. So to print reachable nodes from source node. Okay, the method we are following for this is equal to BFS method. Okay, using BFS method. You can use any one of that. Just for understanding purpose, we are implementing both. Okay, so and third option we are giving to check whether graph is connected or not. Okay, this is we are doing it using BFS method. Okay, in detail we are going to study BFS and DFS in the fifth module. And finally, what is the fourth choice? It is the exit case. Okay, so then specify the user choice. Via scanf, read the choice. Okay, so follow the switch case. Okay, so we will start with the case 1. So what is the first case here? First case is to create the graph for n number of cities. Okay, user should enter the value of n. For doing that, go with the printer statement.
Ma'am, S ಆಗೈತೆ ma'am ಅಲ್ಲಿ. Choice E ಆಗ್ಬೇಕಾಯ್ತು.
Yeah. E. Okay. So enter the number of cities. Okay, cities to be entered. How do we fetch the cities? Via scanf. %d. Okay, %n. Okay, so now you know the city details. But how do you create the adjacency matrix? Can you people tell me how to fetch the adjacency matrix? Heng read ಮಾಡೋದು adjacency matrix. When n value is given, when n is equal to 3, so it indicates there are 3 nodes. Okay, for 3 nodes, I should get the values of adjacency matrix for the given graph. Okay, you need to write down the graph in a paper, then specify what is the matrix, then you have to give that as an input here. Okay, how to read 2-dimensional matrix?
Using 2 for loops.
So using 2 for loops. So I'll go with I is equal to 0, I less than n, I plus plus. So which matrix we are reading now according to our declaration?
Adjacency matrix.
Okay, ADJ, adjacency matrix. So scanf, read the adjacency matrix. %d, it is an integer type. Ampersand ADJ of I and j. You should have 2 index here because for it is a 2-dimensional matrix. Okay, then you come out of the particular case. So this is the only thing you have to do for the case 1, that is to create a graph of n cities. It is very simple actually. You get the value of n, based on the value of n, read the adjacency matrix. Okay, so before giving the input for the case 1, make sure that you write down the graph on your own in your book, write down the adjacency matrix. By looking at the adjacency matrix which you have written, then you have to specify the values here. Simply, if you enter random values, you will not get the proper output. Okay, that's all about your case 1. Okay, then we will go with case 2. Okay, so what is case 2? Case 2 is to print the reachable nodes from the source node. So we need to specify what is my source node. Okay, I have to read what is the source node. From source node, I will be applying the BFS method for identifying what are all the nodes visited. Okay, so for doing that, first read your source node. Okay, enter the source source vertex to start traversal. Okay, so it can be any value. You can give any input for the source. So what is the variable we have considered for source?
SRC.
Okay, SRC ampersand SRC. Okay, so now we have to write a separate function for applying BFS method. Okay, for doing that, I'll just give the display option here for printing the reachable nodes. So what is this? What is this are the examples of the nodes, every nodes. So if it is singular, we will call it as vertex. If it is plural, it is called as vertices. Okay, so vertices visited or from the source node. Okay, from the source node, what are all the vertices I can visit can be known via your BFS method. Okay, so now I'll call the BFS function. We will write the separate function for BFS. Okay, for BFS, what are the things to be passed? I should know what is my source node. Okay, input should be, input parameter for BFS is, I should know what is my source to check what are all the other cities I can reach. Okay, if I know that I am in Tumkur, I can check what are all the other cities I can visit. Okay, that is the thing. And how do I get the path details? Whether I have a path from one node to another node, what should be passed? Where do you get that? So from adjacency matrix, correct? So from case 1, we have already read adjacency matrix. From adjacency matrix, you will identify whether the particular node is visited or whether it is having a path or not. Hence, we are passing adjacency matrix, and along with that, to stop the particular iteration, I should know the number of cities. Okay, so n is the stopping criteria because it should be repeated until you visit all the nodes. How do you get whether how many cities are present or not? It is depending on the value of n. Okay, hence we are passing all the three values here. One is the source node. I need source node and I need adjacency matrix to check whether there is a path or not. And to stop the iteration, I should know what is my value of n. Okay, so this is the function call. Okay, so after this, you can directly come out of the particular case. Okay, we have to write the function definition for BFS. Okay, before that, I'll just complete case 3 also. Okay, so what is case 3? Case 3 is to check whether the particular graph is connected or not. Okay, again, you should identify what is the source node. Okay, from source node, you will check whether I can visit all the other nodes. If it is visited, then I can say the graph is connected. Okay, so here also you should check or you should give the input as what is the source node. Enter the source vertex to start, because you need to traverse first, then you have to check whether it is connected or not. All the nodes are visited, then only I can say it is connected. Okay, So scanf percentage d and source. Okay, so afterwards, so what you can do is initially you know the value of particular visited array is equal to 0 depending on the value of n. Okay, initially what we can do is you can do two things here. This visited values you can specify globally. If it is a global declaration, no need of specifying the initialization value here. Okay, because you are doing it locally, we are initializing it to 0. Okay, so depending on the value of n, you can restrict the visited array. Okay, visited array can be restricted. How can I restrict the visited array? For I is equal to 0, I less than n, I plus plus. As of initialization, I'll make visited of I is equal to 0. So why we are going with this particular method? So for total number of nodes, for the nodes, okay, we are initializing it to 0. What is the meaning if it is initialized to 0? Nodes are not visited, correct? Okay, so based on the value of n, for all the values we are making it to equal to 0. Suppose if you do it globally, this thing is not required. Okay, if it is global declaration, this is not required. So you can eliminate these two lines. We shall check this after execution. Okay, so now we have to call the DFS method for doing the traversal. So normally like DFS also requires the value of source node and it requires the adjacency matrix. Along with that, n is also required. Along with n, to check whether the graph is connected or not, you need another value here. Can anybody guess what is the value here required here? N is required. These three is required. You know, source, adjacency, n is required. How do I identify whether graph is connected or not?
Using visited.
Using visited. I told you this, right? When visited values are equal to 1, it indicates the graph is connected, correct?
Yes,
So
ma'am.
for that I need to pass visited value also. Okay, so both are same, almost BFS and DFS input parameters are same, but only thing is we are using this case 3 for checking whether the graph is connected or not. For checking that whether it is connected or not, we are using a variable called visited. Okay, so this should also be passed to your function. Okay, so this is a function call. We'll do the tracing and understand. This is the function call. Okay, so function definition to be written. So afterwards, then we will check for a particular visited array. Okay, visited array should be checked. Okay, for all the values of n, how do we print it? We'll understand. Okay, for all the values of n, if visited of I is equal to 0. What is the meaning if all the values present in visited array is equal to 0? Is it connected or not connected?
Not connected.
Not connected.
So when it is not connected, I'll make flag is equal to 1. Okay, this is only for display purpose. We are considering a flag, that is a temporary variable. Okay, if the value of flag, using my flag value, I'm just printing that the graph is not connected. Okay, it is required only for identifying whether it is connected or not. I can print graph is not connected. Otherwise, what is the else case? If flag is equal to 0,
Graph is connected.
the graph is connected. Correct? Okay, so then we will come out of the particular case. Okay, so there is slight difference between case 2 and case 3. Only thing is we have added an additional thing called visited here. Okay, so for all the value of n, we need to check whether the visited value is equal to 0. If it is equal to 0, means for all the values of n, if visited array is equal to 0, I'll be initializing flag is equal to 1. Suppose if the value of flag is equal to 1, we say that the graph is not connected. Okay, so here I can say if visited array is equal to 0, graph is not connected. Okay, then you can come out of the particular case. This is the only addition from the previous case. Then case 4 is just an exit case. If you want, you can add default case also. I'll just close the switch case, then while one, then main program. Okay, so this is about your main function. So it looks very simple if you understand it. Just displaying the options, reading the two-dimensional matrix, then calling the BFS method, and third case is to call the DFS method. Along with that visited array, you are checking whether the graph is connected or not. Okay, so now we'll just write the function for BFS and DFS method. Okay, I'll start with DFS method, or you can start with case 2. Case 2 is BFS. Okay, I'll start with BFS only. So let us write before main to avoid the function declaration. There is no return value for BFS, hence it can be declared as void. Okay, and what are all the input parameters? It is source, adjacency matrix, and n. Okay, that is the input parameter. Int source, adjacency matrix. It is a two-dimensional matrix. Then int n. So these are the three input parameters. Okay. So as I said, BFS method will be implementing with queue concept. Okay. So hence for implementing queue, I need an array. I just consider the array as queue of some size 20. Okay. And front is initialized to 0. Normally, when you consider a queue, what was the earlier value of front and rear?
-1.
So can anybody guess why front is equal to 0 here? Because we know our source. Okay, source is already known. Hence, we will be starting that value of front is equal to 0. Okay, so we shall check why front is equal to 0 and rear is initialized to -1. Okay, afterwards I'm just initializing, declaring two other variables, v and u. Let us check why it is required, and visited array is required to check the connectivity. Okay, so check whether it is equal, initialize that value to be equal to 0. So all the value in the visited array is now equal to 0. Okay, afterwards, so as I said, initially your source will be inserted to queue. How do I insert to queue? What is the option? What is the procedure followed for inserting to queue? Queue is my array. For this array, I need to insert my source value. Recall the queue program.
Q rear
Where will
plus
be
plus
implemented now?
Q
Rate
plus
should be incremented, pre-increment or post-increment.
pre-increment.
So rear is -1 initially. I need to pre-increment the rear. Okay. So because it should now point to 0, then you have to insert the source. Okay. So initially we are passing, or we are assigning the value of source, or you can say we are doing the insertion operation for the queue. Okay. Source is now inserted to your queue. After it is inserted to queue, what happens to your visited array? Visited array of that particular location. Okay, suppose if source is the first location, what happens to this position? Since it is already visited and we have placed that to Q.
1. It
It
becomes
will be
1.
equal to 1.
So visited becomes equal to 1. Why it becomes equal to 1? Earlier visited was all the values were equal to 0. Okay. When you visit the source node and you place it onto Q, what happens? In that source location, the value of visited will be equal to 1. Okay. So then you need to print the particular source node, because we need to print the vertices. Okay. So how do I print it? Just for printing the source, I can consider source. Okay, source is printed. Okay. So now we have to check for each of the other unvisited nodes. Okay, source is known. From the known source, I need to check all other nodes which I can be reaching from the particular source node. For doing that, what I can do, I can have a while loop for that. Okay, suppose if the value of front is less than or equal to rear, this is a repetition step to be done until I visit all the nodes. Okay, so then you pop out the node which is available in the queue. What is the node available in the queue? Queue ಅಲ್ಲಿ ಏನಿದೆ ಇವಾಗ?
Source.
Source.
So how do I pop it or delete it from the queue? What is the
Find
procedure
front.
for deleting? Huh?
Front.
Front increment.
So from
Not-
front, I can pop out. Okay, after you delete, what should be the option of front? Is it pre-increment or post-increment?
Post increment.
Post.
It is a post increment. Okay, initially you will fetch that location, then you are going to increment the value of front. Okay, so consider a situation now. In the queue you have a source node and I have popped out the source node. Okay, from this source node, U is my source node according to this particular iteration. From this U, I need to check all other values that I can visit. Okay, for doing that, let us consider the for loop. Okay, take the value of v. Just for, you can take I also, it is not problem. It is not mandatory that you need to take always I and j for your for loop. You can take any other variable names. It is just a variable. Okay, so you have to do the repetition. How do you check whether you have a path? Okay, consider your source node. So how do you get the value of source? This is your source. U will give you the source details. Correct?
Yes, ma'am.
U is your source. From U, I need to check whether there is a path to other nodes or not. How do you check whether there is a path? ಹೆಂಗ್ ಚೆಕ್ ಮಾಡ್ತೀರಾ ಪಾತ್ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ? What is the input for this program?
I'm using adjacency.
So from adjacency matrix, I can check whether there is a path from the source node to other node, correct?
Yes, ma'am.
Okay, I'm just considering the adjacency matrix here. What is your source node? ಯಾವ ವೇರಿಯಬಲ್ ಅಲ್ಲಿ ನನಗೆ source node ಸಿಗ್ತಾ ಇದೆ?
U.
U. Okay, what is my destination? ಯಾವ ವೇರಿಯಬಲ್ ಇಲ್ಲಿ ಹಾಕ್ಬೇಕು ನನ್ನ destination ಗೆ?
V. V.
V, correct? Why V is considered? Because U is my source node. V ಎಲ್ಲಿಂದ start ಆಗ್ತಿದೆ? V is starting from 0 to n. Okay, so this can be your destination. U will give you the source. V will give you the destination. From source, you are checking for the destination until you check for all other nodes. Hence, we are adding a for loop here. Okay, B is starting from 0, you reach till the last node. We will do the tracing, then we will understand. How do I know whether there is a path? What should be the value present in adjacency matrix when it is equal, when you have a path?
It should be 1 month.
Right.
One.
It will be equal to 1. Okay, suppose from source to my destination, if you have a value in the adjacency matrix equal to 1, it says that it is having a path. But it is not the only condition I need to check here. What is the other condition I need to check? I should also check visited array whether it is already visited or not. Correct? So if the value of my destination, okay, what is the destination? Destination is B. If your destination is not visited, okay, what is the value if it is not visited?
0.
0.
It will be equal to 0, okay. So if both are true, then I can keep on adding my destination to the queue, okay. What is your destination here?
V.
Okay, I'll just repeat it again. Okay, so if you have a path from source to destination, U is the source, V is the destination. If you have a path and suppose if your destination is not visited, then I can keep on adding the destination to make every node visited to your queue. Okay, my destination should be added to queue. Still only source was added to queue, but destination was not added to queue. Okay, how do I add it to queue?
Q plus plus rear equal to
Queue plus rar
rear
is equal to,
V.
what is my destination?
V.
V is my destination. Okay, so we are just incrementing the value of rar and placing my destination. Okay, so this is the first visited node from source, correct?
Yes, ma'am.
Earlier we placed only source. Okay, only source was placed in the queue. Now we are placing the destination value to queue. Okay, when you immediately place the destination, you print what is the destination. Okay, printf. This is the first visited node. Okay, I'm just printing the first visited node because you need to check all the visited nodes. Okay. BFS method we are using from source to destination. What are all the reachable nodes we are printing? Okay. After this, what happens? What happens in the visited array? My first destination is visited. What
Should
happens
be
in the visited array?
should be equal to 1.
Which one? Which
Visited of
location?
V. Visited of
Visited of my destination should be equal to 1. Correct?
yes, ma'am.
Okay. So that is the end of this particular function. Okay, so if you understand, it will be very easy. Okay, so what is whether we have checked for all the condition? Yes, we have checked for all the condition because we have a for loop. Every time your source will be popped out. Suppose 0 is popped out first time, then you will check whether it is reachable. If it is reachable, you print it. Okay, again your while loop gets repeated. While loop, when front is less than or equal to rar, until that position you are going to repeat this. Okay, how it is done in how it is done with the BFS method is we will just place the source node in the queue first and we will make the visited node to be equal to 1. Okay, source is visited. Afterwards, the queue has only source. Then what you do, you just delete that particular source node from the queue, and from deleted node, that is the source node now, check whether all other nodes are reachable. How do I check whether it is reachable? I have to identify whether there is a path. Okay, U is my source and V is the destination. If it is equal to 1, there is a path. Okay, and if that particular node is not visited, if it is not visited, then only it will be 0. Okay, if it is not visited, then push it onto your queue. Insert that particular destination onto queue. That becomes my first node which have been visited from the source node. Okay, now you are placing first destination node. Afterwards, you make that visited node. The destination node is equal to 1, indicates that my destination is visited. Then again, you repeat this while loop. Okay, while loop will be repeated until you check it for all other nodes available in the graph. Understood now? Any doubts?
BFSಲ್ಲಿ visited pass ಮಾಡಲ್ಲ ಅಲ್ವಾ ಮ್ಯಾಮ್ BFSಲ್ಲಿ
BFS ಅಲ್ಲಿ
ಮ್ಯಾಮ್ BFS ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಮ್ಯಾಮ್ ವಿಸಿಟೆಡ್ ಪಾಸ್ ಮಾಡಲ್ಲ ಅಲ್ವಾ ಮ್ಯಾಮ್ ಅಂದ್ರೆ ಮೈನ್ ಅಲ್ಲಿ ಮಾತ್ರ ವಿಸಿಟೆಡ್ ಮಾಡಿದೀವಿ ನಾವು ಗ್ಲೋಬಲಿ ಮಾಡಿಲ್ಲ
visited here locally we have declared ಅಷ್ಟೇ.
ಓಕೆ
Locally we have declared it to 0 because I need to check whether it is visited or not alva.
ಎಸ್ ಮ್ಯಾಮ್
Okay, if you want you can pass it from particular function call itself.
ಓಕೆ ಮ್ಯಾಮ್
ಹಂಗೆ ಮಾಡ್ಬೇಕಂತ ಏನಿಲ್ಲ, you can do that also.
ಎಸ್ ಮ್ಯಾಮ್
So why we are passing from in DFS, why we are passing from the function is, in DFS I need to check back whether the graph is connected or not, correct?
ಎಸ್ ಮ್ಯಾಮ್
Hence I need that value in DFS. Visited ಅನ್ನೋ value DFS ಅಲ್ಲಿ very important ಆಗುತ್ತೆ because I need to check whether graph is connected or not. But ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, we are just checking whether that node is visited or not. If it is not visited, then we will continue visiting it ಅಷ್ಟೇ. Okay, you can modify that, you can pass the value from here also. But ಇಲ್ಲೂ visited ಅಂತ ಕೊಡ್ಬೋದು. Already main ಅಲ್ಲಿ visited 0 ಗೆ initialize ಆಗಿರೋದ್ರಿಂದ you can directly pass it from here also. Correct?
ಎಸ್ ಮ್ಯಾಮ್
Okay, to avoid multiple declarations, you can avoid that also. Okay, everybody understood?
Yes, ma'am.
Yes, ma'am.
Okay, we'll go with DFS. Actually, you have to do the proper tracing for this program, then you can easily understand. Okay, input parameter for this is source and adjacency matrix and visited array and n value. Okay, so here DFS we will be using stack. Actually, you can define array for stack, or you can also go with the recursion concept here. Okay, so you already know recursion will also make use of, it is an application of stack. So system stack will be used. So to make it simple, I'll be going with recursion here because it is an application of stack. It is also using the system stack itself. Okay, so DFS method we will be using stack operation. Okay, so just initialize the temporary variable called k. Okay, so initially since source node is already visited, what should be the value of visited? It is equal to 1, correct? Okay, just for initialization, we know that the value of source is passed from the main function. So we are checking whether the source is equal to 1. We are initializing source is equal to 1, indicating that the node is visited. Okay, so then we will go with checking whether reaching all other nodes. Okay, so source is known, k can be my destination. Okay, so how do you check there is a path? It is same as your BFS. Tell me now.
ADJ
Okay.
source
Okay.
and K equal
K
to
is the destination. Okay.
1
Okay.
and visited
Ah.
visited of K
Okay.
equal to 0.
Okay. Then we have to push it onto stack, correct?
Yes, ma'am.
So for doing that, instead of storing that push pop operation, incrementing that to reduce the total number of lines, what we can do, we can directly go with a recursive function call where you will be passing the value of your destination. What is the destination value? K is my destination, and pass your adjacency matrix, pass the value of visited and the value of n. Okay, when this is called, what is the source in next iteration?
K.
Okay, so K becomes the source for the next iteration. Okay, for the next iteration, again you check whether there is reachability from K. If there is a reachability, again you call this DFS until you visit all other nodes. Okay, only this thing will be taken care. Okay, because it is a recursive function call. Every time you are changing the value of K. Okay, so this is the complete program. First, I'll execute this program, then we can go with doing the tracing. Actually, for understanding this program, you have to follow the proper tracing. Okay, I'll just indicate that as graph.c. Okay, so then compile the program. We have one error. Statement missing. Okay, semicolon is missing here. So now compile, there are no errors. Okay, so this is the program to perform the graph operation. So what is the first choice? I'll go with the first choice is to create a graph for n number of cities. I'll just give the value of n is equal to 3. Okay, so when n is equal to 3, now we have to enter the adjacency matrix. Okay, so I think in the program I missed adding enter the adjacency matrix. Directly I have given, I think. Okay, so I'll give the adjacency matrix based on the input. Okay, we'll do one thing. One second, I'll show you the matrix, because without matrix you cannot. Okay, so please remember this matrix. Okay, so or you can do for another example where we considered. Okay, it is not there. Okay, one second. See, without graph you cannot do this. Okay, I'll just take the simple example. Tell me the adjacency matrix for this. 3 cities, 0, 1, 2. Okay, so this should be my input. Adjacency matrix is the input. From 0 to 0, it is 0, 0 to 1.
1
Okay,
1 0 1
1, 0, 1.
no 1 1 0.
Okay, so you people remember this. This adjacency matrix I need to give. Okay, according to the example, my output should be, it should be connected graph, because all the nodes are connected and I can reach any other node from the source node. Okay, so now we will check. You have taken note of that, right?
Yes, ma'am.
Okay, so I'll just go with graph.c. Okay. And one more thing I missed is here, printf, it is not displaying. It should display enter the adjacency matrix. Okay, so now you can go with compiling and run. Okay, so go with choice 1. Number of cities is equal to 3. Now I need to enter the adjacency matrix. Okay, it is 0, 1, 1 and 1, 0, 1, 1, 1, 0. Correct?
Yes, ma'am.
Okay, so first choice is done. We have created a graph. Okay, and we will check the reachability from BFS method. That is the second method. Okay, so second is, so while entering the second choice, you need to give what is your source node. Okay, initially I'll take 0 as my source node. So from 0, what are all the other nodes you can visit? What should be your output?
1 and 2.
So my output should be 1 and 2. Correct? Is it, are you getting 1 and 2?
Yes, ma'am.
So visited, what is this visited, or actually I'll do slight modification in the output. 1 second. To make it proper, just change in the display, that's all. Okay, so we are printing, which one we were printing? First one, right? What is this visited or BFS? Okay, we'll go to BFS. This is your source, right? Source. Okay. Source 2, or I can make it source. Okay, it's okay. And this is your destination. Destination, I'll just give a space here. Now we will execute. Just for the proper display, otherwise it will be appended to previous output. Okay, 3 cities, 1, sorry, not 1, 0, 1, 1, then 1, 0, 1, 1, 1, 0. Okay, so choice 2, I'll give choice 2, source is 0. Okay, so now you can see what is this visited or source is 0. From 0, it can be visited to 1 and 2. Now it is displayed properly, correct?
Yes, ma'am.
Okay, afterwards I'll change the source. Okay, I'll give another source, same choice is 2. Okay, and source is, I'll give 1. What are all the other nodes that can be visited from 1?
0, 2.
Okay, are you getting 0, 2?
Yes, ma'am.
Yes, ma'am.
Okay, so what is visited, or actually this display can be changed. What is visited from source to destination anta kodbodu print alli. We'll change that later. Okay, again I'll give choice 2 with vertex, sorry, equal to 2. Okay, what should be your output?
0 and
0, 1.
Okay, actually ನಾನು space 2 ಸರಿ ಕೊಟ್ಟೆ. Okay, 1 second. I gave double space. We will change 1 second. Vertices visited, or this is source. Okay, source 2. Okay, just for printing purpose. Okay. So choice 1, 3 cities, specify the matrix. Okay, so choice 2, source is 0. So vertices visited or source 0 to 1 and 2. Actually, earlier case was not saved, answer. Program to perform should be done in next line. Okay, choice 2, I'll give the source equal to 1. So it will display vertices visited or source 1 to 0 2. Okay, again give choice 2 with the source is equal to 2. So source from source node 2, it should be visited to 0 and 1. Okay, so are you getting correct output for all the source node? Is it reaching to all other destination nodes? Yes or no?
Yes, ma'am.
Okay, so now we will go with case 3. What is case 3? Case 3 should print whether the graph is connected or not from the given source. I'll give case 3 and source is equal to 0. Is it connected? From 0, can you visit all other nodes?
Yes, ma'am.
So my output should be the graph is connected. Are you getting the same result?
Yes, ma'am.
So I'll give choice 3 again for the different source. So from source also the graph should be connected. Is it connected? Okay, again from choice 3, I'll give different source. Source is equal to 2. The graph is connected. Okay, you can give any source. Finally, the graph is connected because all the nodes are visited from other sources also. Okay, so this is a simple example. And fourth is finally the exit case.